Alright, so for this lesson, we'll be applying properties of rational exponents. You know the properties of exponents. You have a foldable that's about the property of exponents. You might want to pause the recording at this point and take out that foldable, okay, because they are the same properties of exponents that we used before. The only difference is that now those exponents are fractions. So this is a little display of all of our properties. In case you've lost your foldables, they're all here. And here's a reminder, you're welcome to study this as you want. Okay, so if we look at this problem, then we need to look at study what we have and then think about what to do. So here's the idea. In this expression, we have inside the parentheses a base raised to a power times a different base raised to a different power, and all of that is raised to another power. So what to do first? We ask ourselves, can we multiply the terms that are in the parentheses? Well, no, we can't. And the reason we can't is because the bases are different. So be thinking of this expression, like what if we had, x to the 1/3 power times y to the 1/4 power, and that was cubed. Okay, we can't take x to the 1/3 power times y to the 1/4 power because the bases are not the same. Okay, so the next thing we look at is, well, what rule of exponents can we use? Well, if you think about this expression over here that I wrote on the right, maybe you're remembering, oh yes, well what we can do is we can take this exponent and apply it to each factor inside the parentheses. So indeed, that is what we can do, and that is what is shown up here on the top right. So we're going to take 3 times 1/3, and we're going to take 3 times 1/4, and the base is not affected. Alright? So when we multiply fractions, multiplying fractions is that friendliest operation we do with fractions, and we just multiply straight across. But I do need to write both of these numbers as fractions. So 1/3 is 1/3, 3 is 3/1. These are actually reciprocals. So when I multiply them and get 3/3, that equals 1. So that means the product of 1/3 times 3 is 1. So this is 5 to the first power. Alright, now I'm going to take 1/4 times 3/1. Again, we want both numbers written as fractions. 1 times 3 is 3. 4 times 1 is 4. So this, the product is 3/4, and so this is 7 to the 3/4 power. And that is our answer, 5 times 7 to the 3/4 power. And there really is not any more that we can do with that because 5 is as simple as it can be, and 7 to the 3/4 power, well, we don't know what 7 to the 3/4 power is. We can put it in our calculator and get a decimal, but we do not want to do that. We want an exact answer, and that's exact. Okay, so moving on. Here's some practice for you to do. I would suggest you pause the video at this point and then do your work on your paper, and then when you turn it back on, then I'll have the answers written in for you. Okay, so here's your answers and your work. Check and see what you did, see if you can find any mistakes, and then we'll move on. Okay. So these are obviously a little more challenging than what we saw before, but we're still just following those rules of exponents that we learned back when we did square roots. So starting here in the top left, I can see the base is the same on the bottom and top. It's 4 on the bottom and 4 on the top. So when I have like bases and I'm dividing, I subtract the exponents. So that means I have 4 to the 2/3 minus 1/3 power. Well, when I subtract fractions, as long as the denominators are the same, then all I have to do is subtract the numerator. So I have 4 to the 2/3 minus 1/3 is 1/3 power. Now, since 4 is 2 squared, I could rewrite this as 2 squared to the 1/3 power, which gives me 2, and now I multiply these exponents to the 2/3 power, and that's completely simplified. Alright, over here in the top right, you might recall that when we simplified previously and we had variables like this with exponents, I suggested you spread things out. Well, that's still a good idea. So I'm going to start by putting 6, and then x, and then y to the 3/4. And then on the bottom, I'm going to spread these out and line them up. 3, x to the 1/2, y to the 1/2. And now I'm going to look at these one piece at a time. So first, I have 6 over 3. Well, they both divide by 3. So that gives me plain old 2. There is a 1 in the denominator, which you can write, or being 1, it's not going to have much significance. But if it makes it easier for you to write it, then write it. When I look at this second little factor here of x, I know this is x to the first power. So I need to subtract these exponents. 1 minus 1/2. Well, 1 minus 1/2 is 1/2. So this is going to become x to the 1/2 power. The bigger exponent was in the numerator, so the x to the 1/2 will stay in the numerator. If these had been switched and the x to the 1/2 was in the numerator and the x to the first was in the denominator, then the bigger exponent being in the bottom, this would have been on the bottom. You might want to listen to that again if that was confusing to you. Okay, so now when I get to y, it's kind of the same story. I'm going to subtract these exponents. But I need to first look and see, well, y to the 3/4 is in the numerator, y to the 1/2 is in the denominator. So I know that 3/4 is greater than 1/2. So again, my y is going to end up in the numerator. But to subtract 3/4 minus 1/2, I need to have a common denominator. So I'm going to come down here to the bottom of the screen and take 3/4 minus 1/2. I know that I can take 1/2 and rewrite it as fourths. Now, if you're not sure how to do that, I'm going to come way over here to the left and show you how to do that. I have 1/2. I want it to have a denominator of 4, like my other term. So I set it up like this. And then I'm thinking to myself, 2 times something equals 4. Well, obviously 2 times 2 equals 4. So I have to multiply the numerator by the same thing, because if you look at this, what I've written now is right here I have 2 over 2, and 2 over 2 equals 1. So I'm really taking 1/2 times 1 to get my other number over here on the right. And when I do that, all I've done is rewritten 1/2 in a different form. It's going to still be equal to 1/2 though. So 2 times 2 is 4, 1 times 2 is 2. So we know that 1/2 equals 2/4, because all I've done is multiply 1/2 times 1. So 3/4 remains. I'm subtracting, I'm replacing now 1/2 with 2/4. 3/4 minus 2/4 is 1/4. And so up here, this answer is y to the 1/4 power, because I took 3/4 minus 1/2. So my answer is 2x to the 1/2, y to the 1/4. Since the only thing I had in the denominator is 1, I know that dividing by 1 has no effect on my number, so I don't need that denominator of 1 anymore. That's my answer. So now I'm going to invite you to try the next two problems using your rules of exponents. This bottom one on the left, you might need to think about for a second that this one here on the right should be similar to the one we just did. So I would pause this, try those two, and then when you turn it back on, I'll have the last two for you. Okay, so coming back to our work, I'm going to erase some of this because it's going to be in my way. You're welcome to go back and look at it if you need to. And I'm going to reduce these problems and get them out of my way and give us some space. Okay, so this problem on the left, the first thing we want to do is we check inside the radical and see if we can simplify it, and we can't because the variables are different. So I'm going to have to rewrite this as the fifth root of x to the 10th over the fifth root of y to the 5th, which is one of our rules of exponents that we learned previously. Now, to simplify these, the easiest way is to just rewrite them with rational exponents. So the fifth root of x to the 10th becomes x to the 10 over 5 power, and the fifth root of y to the 5th becomes y to the 5 over 5 power. Obviously those can be reduced, so I end up with x squared over y. So that was actually pretty simple. This one, I'm going to use my spread it out technique. So I've got 14 and 2, x to the first and x to the 3/4, and then y to the 1/3, and that should actually be moved over now that I look at that, but that's alright, and z to the -6. Now those two are obviously different bases, but we'll fix that as we go. So 14 and 2 both divide by 2. So that leaves me with 7 on top. I could write a 1 on the bottom, but I'm not going to need it. X to the first and x to the 3/4. The bigger exponent is on top, so I know x is going to end up on top. I need to take 1 minus 3/4. I hope you all know that 1 is 4/4. So 4/4 minus 3/4 is 1/4. So I've got x to the 1/4 power in my numerator. That's my x's. Y to the 1/3, I have no other y term to cancel it with. So it's just going to remain y to the 1/3. And z to the -6, well, I cannot leave a negative exponent. So to make that exponent become positive, I have to flip that factor to the other side of the fraction bar, which in this case means I'm going to take it from the bottom and put it on the top. So I have z now to the +6th power, because I flipped it to the other side of the fraction bar. The only thing in my denominator here would be 1. So my answer is 7 x to the 1/4 power, y to the 1/3 power, z to the 6th power. Alright, again, if you want to go back and watch that again, you're welcome to. Now, this program will only let me make short videos, so I'm going to stop this video, and you could start working on the assignment if you wanted to and see how far you get, and then there will be another video finishing up this lesson.